Hello and welcome to our Digital Futures session on sand, the latest in a series looking at different materials in construction. We have already dealt several times with concrete, with timber, and our session on clay printing has proved to be extremely popular, over 38,000 views so far and counting. Before I introduce our host today, Marcus Farr, let me briefly just mention what we have coming up in the week ahead. On the 29th of April, we have a session in Spanish looking at robotic fabrication. This is followed by a session on the 30th of April on Saturday, looking at distributed design and innovation, technologies, communities, and ecosystem. This is going to be a talk in English next Saturday, and also next Saturday we have a session in Arabic as part of our series of looking at creative Arabs around the world. Again, the Arabic sessions have proved to be extremely popular. This is all, of course, in running up towards our big festival in the summer, where we will be hosting a series of workshops as before, but this time organized according to languages, and we hope to be building upon our successes of the past. For today's session, however, we are delighted to have Marcus Farr as our host. Marcus is somebody who's no stranger to Digital Futures. He has been for some time a PhD candidate on the Digital Futures program. He originally comes from Missouri in the States. He studied at Druid University, followed by Rice University. He has since been a Fulbright scholar in China, and he's currently a university professor at the American University Sharjah and the principal of a practice called Material Artifact. It's a great pleasure to be able to welcome Marcus here today. I will be stepping back and let Marcus introduce the session, and I'll be joining you again for the questions afterwards. Marcus, welcome.
Thank you so much, Neil. It's a pleasure to be here. My name is Marcus Farr. I'll be moderating today's discussion. I'm joined by Al Borhani and Jumana Al-Hashimi, both of whom have a research agenda that involves sand and architecture. I'd like to introduce both of them now. Al Borhani is on the faculty of the California College of Arts in San Francisco. He has an MArch from Virginia Tech and also from SBU, and is a leader of the Trans Lab. He's authored many scholarly articles, presented work at national and international peer-reviewed conferences, along with authoring 2 book chapters. Jumana Al-Hashimi is a transdisciplinary designer and artist. She's currently pursuing her Master's of Science in Digital and Material Technologies at the University of Michigan, Ann Arbor, and is a selected research fellow. Jumana is the Assistant Director of Research and Visualization and Fabrication Services Department in the Experimental Research Building at New York University, Abu Dhabi. Previously, she worked as the lead researcher for the Qingda Museum's first pavilion, an olfactory museum called the Perfume House. In 2018, she was selected as a fellow for the Salama Emerging Artist Fellowship in partnership with the Rhode Island School of Design. So I'd like to welcome everyone to the session Sand Futures, Architecture in the Age of Diminishing Resources. I'm Marcus Farr. As Neil mentioned, I'll be moderating today's discussion. And we have a simple program of Al, Jumana, and myself giving a brief presentation of 15 to 20 minutes, followed by a discussion of sand as a material as it relates to digital technology and the world of architecture at large. So we start today with a presentation by Al, followed by Jumana, and then myself. Al, I'll let you share your screen with us. And I believe Al's presentation is going to be considering a process called sand formation. We'll explore how to make freestanding shell structures grounded in the self-organizational behavior of sand as a granular material. This material-based approach can help orchestrate the design process rather than the design solution or product. In other words, the main concerns are the conditions of the form finding process rather than the conditioning of the form, moving the discourse from the design of the form to the process of the formation. Al, it's my pleasure to welcome you to Digital Futures.
Thank you so much for having me, and hello everyone. My name is Al Borhani. Beside practicing architecture in San Francisco, I teach at California College of the Art. And today I would like to learn more about the world of sand. And I'm happy to share some project that we've done in a course of schools that I've taught, and mainly I would like to talk about two related experiences. One is done in two freshman courses. The first course happened in 2016 at Texas A&M University, and the second one at California College of the Art, 2019. And after introducing those two projects, I'm going to talk about a research project that our team, including GWS and NEGAR, push forward that one for a while. I like the quote that I put there. The universe may be a mystery, but is not a secret. As long as we can figure out the rules of nature, we are able to work with it. I enjoy exploring the notion of form finding, for sure, due to all great digital platforms that we are working with. The question of form and the question of the legitimacy of form, it's more valid. In the context of my studios, I would like to pursue a student to explore the transition between three main domains: how to be form taker, how to be form giver, and ultimately how to be a form finder. One context that helped us to pursue the notion of form finding was to use sand among other venues. These 2 feet by 2 feet concrete shell are made by freshman students without any background in CAD software or any digital tools. The surface is pretty complex, and they did it relatively simple by using something that I'm going to talk about them in the course of my presentation. I would like to build up some foundation. Let's learn about angle of repose. That I'm going to repeat it for several times in this presentation. The angle of repose, it's a kind of angle that material cannot support itself if we exceed that certain angle. Angle of repose depend on the property of material, how fine or coarse is the moist content of the material, the amount of friction that we have between the aggregate, so on and so forth. And angle of repose is found almost everywhere, from a very small scale to large one, and in many different fields, including construction and agriculture. cautiously or not, we deal with angle of repose. If you design some equipment or if you design a kind of bunker or hopper, for sure, you should know a little bit of angle of repose. Otherwise, all the time, you need to grab your hammer to move material, or you have some difficulty with your equipment. Sand is not widely used in architecture, but we have some great precedents from Hans Eisler to Frei Otto to University of Stuttgart and Gramazio Kohler research at ETH. All of them try to push the boundaries. In a specific, I would like to provide you some context, what's going on with sand. If you have a shoebox and fill it with sand and wait forever, the shoebox is not going to be completely empty. And this is a question that all the time I ask it from my student, and normally they don't think that the shoebox is not going to be empty. Because of the angle of repose, some material is going to leave there. And if you have a box with different holes, as long as you open up the holes, a certain kind of shape are going to emerge. And if you repeat this experiments 100 times in every part of the planet, probably the outcome is exactly the same. The angle that you see here between the surface of box and the body of sand, it's about 35 to 37 degrees, depending on the fineness of sand particle. And by altering and playing with simple geometric aspects such as distance or size or location, orientation, you can make different patterns. And it's interesting, just by moving some holes, you switch from quad grid to hexagonal grid. We can get benefit of this principle for making more advanced kind of patterns. In previous slide, you saw just one hole, but if we replicate the hole and create a line, the possibilities would be endless. The line could be a straight or curved in any manner that you may imagine. In spring 2016, freshman student at the end of a very long semester, they ended up with sand formation process. Prior to this design activity, they use CNC. They made some mold to cast plaster, and probably this design activity was a kind of turning point for them. In the previous assignment, they force material to take the shape that they wish, but here the goal was to talk and negotiate with the material, and the ultimate goal was to remember that a designer is not the only decision maker. We started with a couple of quotes. The beautiful conversation of Lee Khan with Brick, and when Khan asked what you want to be, Brick, Or another beautiful quote by Fry Otto, when he said, architect is not God the creator, architect should be a midwife. Means you try to provide a condition and negotiate between different aspects of your design. A student made a shared box. It was really end of the semester, and they were almost broke in regard of spending more for the studio, but they made 2 feet by 2 feet boxes, and they tried to make this concrete shell by using sand. They use sand as a formwork and simply use sand for several times. Some examples of front side and back side of the shells. And it was interesting, the journey from 2D to 3D, a very simple way of making a couple of holes on a board, and immediately could jump to the excitement of 3D work. The process was about adding cement on the top layer of sand when some water used to make the shell. Here we can see a simple diagram that shows maybe 2 different ways to make the shell. One way is to mix cement with sand in beginning, and then go through formation. But here we decided to use sand as a kind of pure material, and do not contaminate it with cement, as long as we wanted to use it for many times. As long as we decided to keep the sand pure, so we add water and we add some layer of cement. Here probably we can see the process. This is the first shoebox that was used to see how it works, and this experiment was done by Fry Otto many years ago, and we tried to stand on the shoulder of giant. If I go fast forward, here you can see the holes are open, and sand simply fall down. And then when we have the 3D form, water was added and cement in layers create the shell. Here you can see the first shell that was made, and then based on this quick experience, we could go forward. These are some shells that my student at California College of the Art made them in 2019. Here we try to explore more aspects of sand formation, try to be more courageous to push the boundaries. And this is the assignment that I told you before, sand formation, when we force material to take the shape that we wanted. And it was very interesting. The same student that made the right patterns could make the left patterns, means the same underlying geometry on both. Maybe the flesh is a little bit different, but the structure of both forms are exactly the same. Here, I would like to talk about another method. It's about dumping sand on a plate. Again, it's based on angle of repose. When you have a square, the outcome would be pyramid, so on and so forth, and depend on different boundary condition, you create different kind of three-dimensional form. We got benefit of this advancement to think about a kind of a space architecture, what might be a kind of habitat on the moon. This journey was started with the question of what's happened if you want to take one brick from Earth to the moon, how much you should pay. Based on NASA estimate, you should pay $250,000 for moving just one brick from Earth to the moon. And still we are talking about moon, not Mars. I would like for whoever that wants to make anything on the Mars 6 times more expensive. And the question is how we can get benefit of the existing material that are on the moon, and try to think about, okay, we don't have any shoebox over there, and if we want to make this kind of shell, what we can do. Probably dumping could be a solution, and maybe the surface could provide some opportunity for 3D printing. It would be a kind of a scaffold. This is one project that we were inspired by Voronoi pattern created through sand formation. This is 20 by 8 feet wall for Autodesk Gallery in San Francisco. And surprisingly, the pattern that was created in Grasshopper was made exactly when we use sand. Means the abstract world of mathematics found itself in the world of nature. Okay, let me go closer. Okay, this is the final one. For sure, it is not sand, but it gave us some opportunity to implement the principle of sand formation. The wall was made by kerfing and by plywood, but some inherent property of those Voronoi could be investigated later. For example, the acoustic quality for sure is going to be promising. This is the last thing that I'm going to share with you. A project that Jiris Alali, Nigar Kalanta, and myself were involved. Jiris for a long time push it forward. Jiris came to California College of the Art for pursuing his master's degree, and the goal was to think about low-tech and high-tech. The way that this research pursued was to think about one formwork that could create many tiles at the same time when we got benefit of angle of repose. By making a device and having some opening, we could create different tiles. The design question was about condition of edges. As long as we turn the device, the material doesn't have any tendency to create the same curvature for every tile. And then we decided to push it forward. The solution that Jiris ended up was to create the edge free, and the goal was to have a device that simply we can take it to a site and do the process of casting over there. And by changing simple pieces, different part could be made. Here, a grasshopper definition was defined to do simulation quicker and faster and see the result in a case that we could not do prototyping, especially during pandemic. And when we do some scan analysis and compare the shell that we made with grasshopper model, it was pretty accurate. Here you can see different kind of pattern. Panel could be made by changing simple part, and it could be a possibility to think about some kind of fenestration, some kind of tessellated tile for building envelope. And by using dumping system, Escher patterns was investigated. And as you can see, the process of formation, it's super fast. And then the question is how you are going to use the formwork to make the tile. And at the end, some structural evaluation were conducted to see how much they are going to carry load without using any material at this point. We didn't add any fiberglass or any material to the combination of cement and sand, but for sure more line of investigation is going to push forward. This is a brief introduction of something that we enjoy in the last couple of years, and hope to learn more from our discussion. Thank you.
Al, thank you so much. Inspirational. So many questions I have for you already. It's a pleasure to see that work. Now, I'd like to introduce our second guest. Jumana Al-Hashimi is with us. And Jumana's presentation will first look into sand material explorations done on a micro scale using laser sintering processes. The second will look into macro scale implementations and its use in the potential interaction between sand and water and green facades. And Jumana's presentation will close by looking into applied digital fabrication strategies that allow for sand to remain transient and take part in a dynamic ecosystem to help us reshape our experiences with materiality. Jumana, welcome to the session. It's a pleasure to have you here. And I'll let you share your work with us. Looking forward.
Thank you so much for gathering us today as well. Let me just share my screen. Well, thank you so much, Marcus, again. And I feel like this talk has been very fitting, especially since Earth Day was like literally a day ago. And so my topic is really looking into shifting sandscapes, looking at the micro and the macro and the dynamic of sand properties. So my experience with sand has been really incidental. I really started working a lot with direct metal laser sintering technologies, specifically with US 3D printers. And EOS is one of the leading German companies that have really worked with the bed-based fusion and really the disposing of materials on a layer base specifically. And at that time, I was really getting trained as an applicant engineer in Germany. So I was going back and forth. And at the same time, I was actually doing my fellowship at the Rhode Island School of Design as well, and learning glass for the first time. And I really felt like this process was extremely insightful. It was almost like this eureka moment that I had, where it was like, it's, you know, like really looking at granular materials as really developing and being and really trying to transcend them from their to another state, from sand to glass, for example, or from scattered to gathered, and really looking at these different explorations that I've done. And so these are like basically artworks that have been created throughout my fellowships that were really sort of the spark that started everything. And here it's really working a lot with silica sand and glass, and it's a body of work that's called Through the Fabrication of Time, where you see on the left is really the hardening of the sand with water-based binders. And really on the right, you would see the sintering that's happening, which is sort of like this faded text that's actually really sort of a fragile glass that's starting to form from molten glass that's been happening because of the sintering process. And so this is also another trial into trying to see, well, if I were to use another kind of sand, which is not really silica sand, that doesn't really have as much silica properties, like desert sand, for example, and really trying to use it with certain water-based binders, such as sodium silicate, that has some silica components in it, and really allowing for that forcefully allowing for that, you know, glass to emerge on the surface. Which is also another body of work that has been showcased across the United Arab Emirates. And to be honest, it was a really inspiring journey, because it's really started getting me into these other disciplines, and really being a transdisciplinary designer and artist, I really believe that there's a really great relationship or sparks that really happen from really trying to shift between different or travel between different disciplinary borders. And through this work, I actually ended up to pursue my master's in digital and material technology at the University of Michigan. And so I wanted to really start looking at the micro. So what is sand as a granular material, and what really happens on a micro scale? And in here, what I was really trying to do is really understand the difference between silica sand and desert sand specifically. So I'm from the United Arab Emirates, and the desert is a landscape that I'm extremely familiar with. And it's a landscape that I've been exposed to in my entire life and have extreme appreciation to, and really believe that it's become a part of not only in like a natural phenomena, like the desert being a natural phenomena, but also being a part of this culture and identity of trying to really preserve it as much as you can possible. And so I was really looking into desert sand and silica sand on a micro scale, as I said, and really looking into what makes them different, and why is silica sand more favorable, and why is desert sand really frowned upon in the industry. And really, the problem is with desert sand is that the grains are really traveled by the wind, and the wind actually makes them extremely rounded. And for that reason as well, it makes them really unstable, so you can't really bind them properly. While on the contrary, with silica sand, the grains are extremely angular, so they fuse better, and they're mostly shaped by water, and they're found in beds and banks and floodplains of rivers, and in lakes and in seashores. And because it's also silica sand, it's also used to create most of everything that it has made up the modern world right now, such as glass, skyscrapers, you know, the houses, and really roads as well. And really, as far as going to your iPhone, and to really having parts of our computers even made from glass, and it's become such a high demand resource. And so what I really did first is that it's really simple. I have just scattered a couple of sand onto the bed of a laser cutter, as simply put as that. and really trying to sinter as much as I can possible and very slowly and with the highest power possible that the machine would allow me is to really sinter as much possible and try to create create glass. Sorry. So as you see on your right is really seeing it more under the microscope, and on the left is really seeing it in its real scale. And then after that, I really wanted to see if possibly there's a way to fuse the sand together while also creating the sintering process as well. And in this case as well, I have also worked with water-based agents, specifically sodium silicate. So what I did as well is really as simple as just going through hatching patterns that are just sintered by the laser. And really, as you can see at the bottom, is really the glass that is sort of trying to emerge while also keeping it bonded. And this is more on a finer, using finer grains of silica sand. And as you can see, the order, because it's quite fine, it looks extremely neat when it comes to the laser sintering, and the glass really penetrates through even nicely. And it's really trying to see in terms of like what really occurs with the sintering as it's creating this molten glass. And the more that you run through this, run it through the sintering process, it will keep forming more glass. But it takes a really long time though. Like this piece took about 4 hours to be able to actually sinter it to something close to glass. So as I mentioned as well, being from a country that is extremely dominant by the desert, but also it's being depleted by the desert because of, you know, the modern age and having to expand. But this is really an image that I've taken at Sharjah. I'm sure Marcus would be really familiar with this place. It's really known as a ghost town right now. So they've built this entire neighborhood that has become you know, that has become abandoned because of the reason of the moving of the sand and the wind constantly having to push the sand inside these houses that have become abandoned. And it really shows you just how remarkable and how strong and dynamic winds can really move particles from very large distance into creating these really large volumes and bodies of landscapes. And so in this case as well, I was thinking of, okay, since desert sand is not really as accepted in the industry and as reliable as it may be, but it's really trying to see if there's a way that we can employ desert sand and really try to create silica out of it. And it's also working as well with sodium silicate and trying to allow for that force of glass forming, which I sort of call sort of glass, and really seeing if there's a way that this could be employed and if it can also give it some more properties as it were to give it to the other tests that were made. So now it's really looking into the macro and looking more on an architectural scale and really trying to see how sand can be really a material that allows for the delivery of water, specifically through capillary action. So this body of work was really made with great colleagues of mine that really have been such a pillar in making this happen. So this is a project called Wild Wall, which has been done in conjunction with a class last semester that I've taken in University of Michigan called Material Engagement, that is under Dr. Mania Maybodi. And it's really looking into creating a green facade that can be, you know, powered by some form of capillary action that allows for the water to keep going, that allows for the collection of rainwater, and really allowing for it to resurface back into the facade by a capillary action. So this is sort of a concept that has been really just in the conceptualization phase. So It's really looking into incorporating the sand inside and really as a way of insulation, but also as a way to allow for the movement of water to surface up to the pods, which you will see later. So these are just some tests that we've done that we believe might work, but this really has to still be studied even more and really seeing if it can be employed. So the project was mainly looking into 3D printing facades and really, we were working with plastic pellets because that's what we had for the time being, and that's what the extruder, the end effector, was really working on. And so what we did is that we designed these like pods that are sort of ranging in size according to the plants that it would house, and it's computational and it can be changed. And really, what you can see on the left is sort of the sectioning of the 3D printing that really allows for these pods to really form. And then on the right, you would see that sort of like a conceptualization of a section that we have, really looking into how the sand could really be housed within this structure, within this facade. And what's really amazing about 3D printing is this allowing of 3D printing multi-layer facade in one go, rather than having to add these different aspects of the facade. So the prototype took about 64 hours, and it was around 9,427 meters. Of course, we didn't reach all the way to the top because unfortunately time is of the essence, but we were able to really reach to the first 4 levels or sections of 3D printing. And of course, it's limited to how much the robot pendant can really hold as a file size as well. So this is really the process of 3D printing it. So and really creating this path that could really be continuous, and also generating these pods and seeing if there is a way that we can actually house a couple more materials inside. So this is basically the process video. So this is the back of the 3D printed facade. And this is the second layer of 3D printing. So this is basically just a prototype that we have been able to 3D print. And it took around, if I'm not mistaken, 40 hours, 36 to 40 hours. And it's really showcasing how these, and really we've added some plants in there to just see how they were being housed in the pods. And this is sort of an artistic shot into really seeing the scale. So now I'll be shifting into really looking into the dynamic and really allowing for sand to become, to allow for impermanent structures to emerge, and also allowing for it to be transient. And to be honest, as Borhany, as Al has mentioned as well, is that sometimes it's good to let go as a designer and really allowing for the material to really flow the way it should flow. And it was a really great exploration into understanding how sand particles really accumulate and amass, and really thinking of a way to really work with that. So this is a really very interesting phenomenon that happened in Michigan. It's happened at the Lake Michigan and Lake Michigan Beach. And what happened is that there was really these sand formations that have been happening next to the beach because of the very low temperatures and the very strong wind. It started to really create these forms that might not have happened in any other kind of ecosystem. And it was really permanent, and it just happened, and it was occurred for a day. And it's really showing us this idea of temporality and really trying to study these forms that happen within the ecosystem that can really teach us about how materials are not as we expect them to be, and they can even emerge into other forms. And so there was a lot of great site study that we've done during a class called Advanced Prototyping that was really led by Katie Newell, Professor Katie Newell, and she really took us onto this site called Pelston that is located in the biological station. And what was really interesting is that it was my first time to ever experience a 4-season weather in my life. So to be able to see something that's as resemblant of the wind movement that is tracked within the surfaces of the dunes, and to really seeing it onto snow was really exciting, and it just showed the strength of the wind. And these were just some photos that were taken as an inspiration. And then what was really interesting is that there is a lot of outwash sand that occurs in the place because of the amount of water, the moving water that's really moving all of the sand around, and the sand that is really found there is around 90% silica sand. So what I was really looking into doing is that really designing this path, or this sort of like really simple movements that really allowed for the robot to move the grains around, and not really dictating exactly how they might look like, but really trying to see and understand how the grains were to form. So as you can see here, it's such a very sort of clean curved surface, but that, as you can see here, with the path of the tool as well, that allows for these different surface articulations to really emerge. So there is one over here, and then this is actually sort of a very quick study that I've done. So this work is sort of still in progress right now, but basically really allowing for this incremental forming of the sand as well, to really go down very slowly, and to really allow for the arrangement of the sand grains themselves to really try to rearrange themselves within this path. And really created its own sort of path. So as you can see here, it's almost like the path has been offsetted somehow, which was really interesting. And sort of what I did is that I have slowly sprayed onto it just some sort of water-based binders to just allow for the hardening of it softly, to really allow for these different articulations of the surface to remain, and to allow these really thin shells of sand to form. And it was a really quick study that I've done, and it's currently still under work, but it's really interesting how thin but how strong the shell has been, and it's been sitting on my desk for a really quite good time now, and it's really surviving. And it's really, the next step is really looking into seeing what happens when you apply a very strong amount of wind, and what happens when you really put it into these different weathering conditions that occur in nature, and especially in the 4-season climate, where you actually have rain, and you have snow that is accumulating on the surface, and also have very strong winds that could really allow for this movement of sand to really take place again, especially since the structure is not as perfect or as pristine as it should be. And that's basically it. Thank you.
Okay, Jumana, thank you so much. Really inspiring. I can't wait to get further into your presentation and also Al's. So now at this point, I'm going to also present some work very quickly, and then in 15, 20 minutes, something like that, we'll get into a discussion about the work and about sand as a topic, and about a material in architecture and design. So I'll go ahead and share my screen with you now. Okay, hopefully you can see my screen now. Okay, wonderful. So I'm Marcus Farr. I'm the director of Material Artifact Studio and also associate professor at the American University of Sharjah in Sharjah, UAE. And I'd like to briefly introduce my research on sand now. Really, my work explores how biomaterials might integrate with dune sand, specifically, and how regionally appropriate architectural systems in the Middle East might synergize with that. So some questions that I'm looking at now are, what are the differences in building with dune sand compared to marine sand or river sand, for example? And specifically, it's looking at using the UN Sustainable Development Goals for making resilient cities and buildings and responsible production for materials for life on land. So sand is interesting to me because it's the most consumed natural resource on the planet beyond air and water. Because of this, there are massive environmental impacts due to river sand mining. Much of this is unregulated, contributes to the destruction of local ecosystems to build buildings that are thousands of miles away. In India and Southeast Asia, it creates sand mafias and contributes to localized crime rings that control the mining of the sand. And in the UN projected that in 2060, that sand and small-scale aggregates will continue to be in demand above all other materials through 2060 because of the almost unlimited need for concrete and consumption of concrete in the world. So this sand that's mined is also being shipped thousands of miles around the globe to build buildings in different regions that are very different from the locations that the sand was gathered. It's estimated that only 5% of the world's sand is used for architecture. And so construction sand comes from rivers and beaches and special mining locations. Marine sand and river sand are very different than dune sand, as Al and Jumana have already mentioned. One is conditioned by water and the other is conditioned by air. And the largest deserts in the world contain dune sand as opposed to marine sand mostly. So a huge percentage of the world's most desired construction resource cannot be used based upon current construction processes. So this for me is an unsustainable relationship between the amount of sand that exists compared to the amount of sand that we use for building. The contrast continues as population explodes and desert cities invest in architecture that fuels a continued need for these processes, and urban centers such as Dubai, which is where I live, Dubai and Sharjah, and the relative proximity to so much unusable sand creates a striking contrast between resources and construction methods. And so the buildings here constructed of steel and of concrete require sand that is much different than the sand that we have in our context. And the sand that we build with comes from Asia and from Australia, which is really interesting as an architect. And so it illuminates an opportunity and a problem. So modern cities, as has been mentioned by my colleagues, cannot be made without sand. Concrete and glass and computer screens and asphalt infrastructure all require sand that comes from 5% of the quantity that we mine. Yet dune sand in the Sahara and Saudi Arabia, the UAE, are currently not used as a building material so much. So my research interests really explore material development using dune sand as a local material resource for architecture in desert communities in the Middle East and North Africa region. So more specifically, as it relates to material, a lot of the materials that are vernacular to this region employ other materials besides sand, mud and coral and other things, shells. But sand is not really found as much as a primary element in the vernacular materials because sand needs a binder. And dune sand is difficult to work with and cannot be used in concrete the same way that marine sand can be used because of 5 primary qualities. Number one, it's round in shape, it's very smooth, it has a particle size that's very fine, and it's alkaline in nature. It's also very dense, similar to dirt, so it's very difficult to work with and to make concrete out of. And so that leads me to my first material experimentation. So the first part of this research looks at how dune sand can be combined with binders to create a sustainable building material for our region. So the caveat here is that toxic glues or resins of any form really are not allowed in the work. So using dune sand sourced from the UAE, paired with 3 biological substances that could act as a sustainable binder. So bacteria, sodium thiosulfate, and urea tests were made for, in this case, for bricks and blocks. And in these tests, sodium thiosulfate was the material that worked the most consistently with the project trials. And so subsequently, this became the dominant material additive with the sand for this particular project. The EPA and the American Federal Food and Drug Administration consider it safe to use in foods such as table salt. And the strength of this varies based upon the amount of sodium or salt and sand added together. So the additive is effective because it changes states with temperature variation, which allows the sand and the salt to bind together in a superheated mixture. And upon cooling, this process forms a strong unit. So essentially we're moving from solid state to liquid state, back to solid state. And the superheated bath of liquid state sodium was poured into a sand-filled mold that was 76 millimeters deep. So this ultimately, material combination was used to create a series of biosynthetic bricks made from local dune sand that simulated standard masonry sizes. And then these were very similar compared to normal masonry in that they have the ability to become dimensionally stable. And then under compression tests, they turned out to be quite strong, reaching 51 pascals in compression for a period of 15 minutes, which told us that the material itself had potential. But the creation of a biomaterial that had compressive strength was really a significant step forward for this particular moment in the research, because it led to the possibility of an organizational system that could be applied to local scenarios in the Middle East, such as namely mashrabiyas and jolly walls, which are very common in the Middle East and also India and North Africa. So since one block size is being used to create the mashrabiya here with a single point of connection in the center, it allows the bricks to be cast exactly the same and operate independently of one another, and also to be cast the same. So this was the result of the sodium sand wall. And this was the result of the wall condition with only 2 of the materials, just dune sand and the sodium. And so this was a step in the research that led us to another material exploration, really because we felt that the sodium was not a long-term answer in terms of sustainability. And so we were looking for additional approaches. And so we looked at some material that's used by the US military to make roads and tracks in tropical locations and extreme climates. This is a low-cost material. It is not affected by the sun. It's also really important in that it's non-toxic to plants and to animals, and it's water-based, which is very different than some other materials that we've used with the sand. And so this is a slump test that we're seeing here. It's normally tested as a spray-on material with road crews to make roads and trails and places for cars to drive on. We tested it as a formative material for 3D printing. And what was desirable with this material binder as compared to what we did previously with bacteria or sodium was that much higher concentrations of sand and compared to additive can be used with this, and it doesn't require a lot of binder to generate a large amount of material. So we tested the workability of this and the castability of this by pouring it on latex membranes. and then allowing those membranes to change sizes, to get bigger and to get smaller, basically by adding air or removing air. And it created a series of iterations that really are kind of these flexible, workable, sandy textiles that start to look like this. They're flexible and kind of rubberish in nature. And this is made from dune sand and one binder, and they're flexible. And so that led us to kind of look further or deeper into how sand behaves as an organizational material. And what's interesting, I think that's come out in the first two presentations for me is that the angle of repose is important to everyone's work. That when you use sand, this is just kind of a part of how you think about it and the limitation. So it becomes a critical threshold, working with piles and small aggregates and angle of repose. And so it's typically between 34 degrees or 45 degrees, maybe depending on the size of the aggregate or the sand. Wheat is different than sand, and concrete aggregate is different than wheat. But this is from Mathematica, and it's really similar to what Al was discussing. When you pile sand on an articulated plane or a limited plane, which is different than an infinite plane that you find in the computer, the shape of the plane can begin to affect the shape of the pile. So round planes create different piles and rectangular planes, etc. And it was really fascinating for me to see that in your work, Al. So when sand is poured onto a lifted plane, with openings, we start to have a kind of response in that. And these primary factors of resting plane, angle of repose, and gravity are used to evaluate these piles in laboratory conditions and in computer models, but they can also be controlled and planned and manipulated. And those exist along with another factor, which is wind. So this is a Houdini simulation video that uses the primary factors of the 34-degree angle, plane, gravity, force that's consistent, along with wind force and wind speed, in order to start to predict the way that sand is going to behave, even though it's something that's very organic and has a very high degree of freedom in how it simulates itself in the natural environment. So on closer look, it's revealed that an ongoing series of these repetitions can be created and can be controlled and used. And so this is a 3D printed block that came from that idea. And this is the other side, kind of both sides, very similar to what Al was sharing with us. And what's interesting to me about this kind of method is that the openings can be controlled, and the top side and the bottom side, let's say, can be controlled, but then it also can start to result in different thicknesses and different aggregations. And then the planes that we use to start to control or stop the sand can also become a way to think about moments of flatness or moments of connection, or other ways to think about how that sand could be used as a kind of substrate. And so here I'm showing a computer model of identical resting sand piles on an infinite plane, which is different than an articulated plane. And we have equal distributions of sand, and the angle of repose is all the same. In the image, you can see the bottom of the pile and also the top of the pile. So computationally, it's interesting because the logic starts with the grid of points, and you can see that the top and the bottom of the sand pile start to become reactive as a field, whereby the movement of one, or in this case, two identical sand piles start to affect the behavior and the geometry of the neighboring sand piles. So that complexity is then doubled in the next version and can be grouped so that 2 becomes 4, thereby increasing the dynamic nature of the sand pile and also the field conditions simultaneously, and so on and so on and so on. So here 6 become 8. And at this point, there's no existing sand piles are left that aren't affected by by a sand pile. So 8 become 10, and so on and so on. And they resemble the formation of the desert. So from that study, there's another kind of iteration of that starts to look at how sand piles could be arranged on planes and then lend itself to 3D printing. So this drawing shows the ability for that to start to replicate itself. Or these sand piles could start to become mechanical or mechanically assisted using digital tools. And then this is a 3D printed version of sand using that model at a larger scale. And so here we're looking at thinking about the orientation of the sand pile itself, but also the ability for the sand pile, the opening of the sand pile, or in the formation of the sand pile, the drain specifically could be larger or smaller and could create different kinds of sandy effects based on the kind of desired tectonic situation, perhaps circulation, water, wind flow, etc. I'll just show some examples of this kind of as a system, different three-dimensional prints using sand and that logic. And that's it for the research that I'll share today. And I'd like to stop sharing and just now have an open discussion with Al and with Jumana and also with Neil. And I see that Philip Juan has also joined us. And just begin talking about sand as a medium and as a material and also as a potential medium for new technologies and digital fabrication. So I'd like to start off just by asking Al and Jumana a question, and that's, what is the potential for sand and technology that you see it in the field of architecture?
Al, would you like to go first?
Sure. As you mentioned, the amount of actual sand that nowadays we can use is very limited, but the earth is covered. The majority of earth, or about 1/4 to 1/5 of earth, is covered by desert, and sand is a kind of abundant material, and it's, I don't want to say free, but it is there if we find a way. Something that is interesting for me, in nature, material is expensive. Probably the most expensive things in nature is material. But for us as human, is not the case. And so we normally don't care how much material are going to be used or wasted, or how we find material and use them. And the slide that you showed, the container full of sand, it's almost ridiculous. It's ridiculous, but it is as it is. Means with whatever method of construction that we have, we need a specific kind of material. I believe sand could be a right material to be explored. And in your work, the way that you cautiously take care of the material means it is, although it is abundant, although it is found in desert as much as we want, but the way that you cautiously take care of almost every particle of the material, it's completely inspiring for me. For sure, with the perspective of 2050, I don't know, it's happening right now, but as we hear, maybe every week, every month, we should make a city in a scale of Manhattan. And the population that we will have on the on our planet, and the limited resources that we had, force us to think similar to you Marcus, and it is a must. Means it is not just a kind of research, sorry to say, fantasy, or pursuing some kind of investigation for the sake of its own. This is a kind of need in the world, and I'm so happy that you work on it and brought this interesting topic on the table.
Thank you, Al. Jumana, I wonder how you might respond to the same question.
Yeah, absolutely. So I really believe that there is this sort of ecosystem that we're a part of, and the materials that we create and we invent and we use have to become a part of this ecosystem, just the way that, you know, things have to decay and be formed, and really going about this idea of creating materials, not just for construction, but also for decay, and really studying this decaying process. So for example, with these, because sand is specifically desert sand, as mentioned, it's very unstable, and it cannot be as you know, as permanent as silica sand or like marine sand. And really trying to really understand and learn from this process, and really seeing what can we learn from the decaying process as well. Will it bring about another life? For example, with your case, Marcus, as well, is really looking into biomineralization, which I think is extremely interesting as well, is that as it's decaying, or as this deposition of this bacteria that's trying to like really harden this material over time, what does that really create? And you see a lot of these phenomena happening in the desert, like the fossil dunes in Abu Dhabi, for example, and Al-Wathba. And it's really, I believe it really shifts this idea from not only making, but also making for, not only making for construction, but also making for destruction, and really seeing what happens to the material when they really wither away, or what happens to them in their next cycle or in their next stage.
Yeah,
and I would like to add one point, Marcus. Although we name architecture as a kind of material-based practice, but the choice of material doesn't have great impact on the formal approach that we take. Means mainly formal concern has some dominancy in practice of architecture. And I should say the material is a kind of servant of form. Normally, material normally does not come as first things. Architects come up with some formal expression, and then they look at some possible tool or material to make it. And beside taking care of a smart material, new material, something that are not fully appreciated in our practice, maybe changing mindset and thinking about material in a more profound way is necessary, in a way that we see how the inherent nature of material is going to be celebrated through the work of architect. Mm-hmm. And in somehow, as long as in our practice the priority go for form, maybe we could not see major things happen quickly.
Yeah, I agree with that. I mean, mindset is so important as when we think about architecture and construction, isn't it? It's the practices of Western building techniques, especially, I think, are pervasive throughout the world. And along with population comes city building, and comes, of course, the need for concrete, which is a material that we really can't live without, but at the same time, it's something that is intrinsically related to the topic of sustainability. It's a material that's highly critiquable, and that 75% of it can be sand and water, and there's a huge carbon footprint involved with that. Importation, moving materials around the globe, and consuming all those materials to make one particular product. However, at the same time, it's also a material that affords us a great deal of longevity. So concrete buildings can last for 100 years or 150 years. And so there's a tension between sustainability and concrete, and sand is at the apex of that particular discussion. But one thing that I'm particularly interested in is the locality of that discussion and how sand and concrete start to diverge as a material opportunity. Like, how can that start to lend itself to other kinds of opportunities, material opportunities for architects, beyond concrete as the sort of dominant material, which probably will be the dominant material for years to come.
Marcus, could I just chip in here? Is it? Yeah,
please.
No,
please.
Thank you for these have been great presentations, and I think you just opened up for many people a whole new area of investigation. I mean, it's been there. It kind of reminds me in some ways of the way that Akim Menges has been kind of assiduously addressing the question of wood, an everyday material that we kind of left behind because we have all these smart materials. But actually, this is the world in which we live, and we need to address this. And there is certain kind of interesting kind of principles to be aware of. That's not to say, I want to just sort of challenge the Louis Kahn thing, that what does a brick want to be? What is the kind of the thing? It's not as though materials have an intelligence. They don't have an intelligence, but they certainly have certain material affordances. And I think the angle of repose and all these kind of issues you were looking at today really open up this kind of question in an important way. And I think, just to pick up on what Al was saying about smart materials, I think there's a real danger that people forget about these, important materials we have and try and invest in what are so-called smart materials in the future. But it seems to me that the key question is not necessarily smart materials as such, if there is such a thing, but rather the intelligent use of how we use materials that we have already. And I think this is what this particular session has really opened up in a fascinating way. And lots of things I had not referred to, I hadn't been aware of myself. I wanted just to go and open up a question. Oh, by the way, if those watching on the live stream, please do send in questions yourself. But maybe a question that I had is I noticed that on the sand dunes that were being shown, there were two levels, shall we say, of material affordances. You get the bigger, the global sort of sand dune, but within that sand dune, you get the kind of ripples of the sand dune. And I wanted just to open up the question of scale, something that I've been interested in the past, and the difference, in other words, between the kind of the large scale operation of the bigger sand dune and the small ripples, because it strikes me that maybe these small scale experiments within the lab might not necessarily translate into larger scale formations. So maybe just let me throw that question out there. I'd be fascinated to see what your response is to this.
Sure, Al and Jumana, would you like to respond to that?
No,
I saw
please
Jumana.
go ahead.
No,
I will follow you.
nodding.
Yeah.
You're muted, Jumana.
Muting situation. So the thing is with really the formations that you see on the surface of the sand, that's really showing you not only the flow of the sand, but also the direction of the wind, and the way that the sand were to form on the other end shows you just how the formation of the sand is really being controlled by the wind, which I think is really interesting. And there has been a lot of talks of Bedouins in the past that have really used it as a form of navigation. And really as a form of settling as well, because, it's really hard. I mean, in a place that's scarce, that doesn't really have a fort, that doesn't really have a barrier or a border, that would actually use the dunes as a way to settle around and really shield them. So it's really amazing to see how really the micro affects the macro. Where it's you see this movement really happening, and you see this dynamical ecosystem that's really occurring, and there is proof of that. And the proof of that is really these ripples that you see, which are really beautiful, but also they really are navigational, and also at the same time they over time they really accumulate. And what's really amazing as well is that there are dunes that are transverse and there are dunes that aren't, and it really shows you just how amazing these formations can happen. And really can be of use of the ecosystem at large, but also it can give us an idea of really how taking it away from a lab, really like outside of that context, and really seeing how can we really create forms that are transient and can really move about, but then what about those that don't move about, and what are really the different purposes for that, which I think could be really interesting and a really great discussion as well.
I think, Neil, we can remind ourselves one thing about the nature of construction throughout history. Buildings were made out of pieces. And suddenly, in one point, we came to conclusion that we can make a huge monolithic things out of concrete. But before that moment, we had to put pieces together to make a thing. And when I look at the bricks that Marcus made for his Mashrabiya kind of things, I'm asking myself, is it a product of lab, or is it impactable, or does it have any impact in the world, in the practice, or is it just something that may happen in a boundary of his lab? I guess if we stand something in between, not in a very small scale, maybe in a scale of Marcus brick, we can find a way to go beyond the lab borders. A couple of years ago, we saw Marcus Kaiser, I hope I pronounce his name in the right way. He made a very interesting solar sinter printer. I believe in Egypt, he 3D printed some vase kind of things. And it's interesting for me, after a couple of years, I haven't seen any other precedent as similar to that beautiful printer. As long as sun is there, sand is there, why not to think about a kind of sintering technique that you, Jumana, work it in a lab environment, but probably it can be come out of your lab place.
Absolutely. And what's really amazing, and I'm really glad you brought it up, Al, is Marcus Kaiser's work is, what's really amazing about it is that it really brought in the machinery to the site, and then really allowing for this abundance of material, since the material is already there, then having to actually ship the material to the lab, because also like shipping of sand is a whole other story. I mean, I remember having to buy desert sand in Michigan, which is not really, you know, it's like buying it off Amazon, and it's like $30 for like just a small bag of sand. Like, that's just ridiculous. And I'm like really used to actually having that abundance of the desert, and really, and this is how I really created my work initially with these tablets that I've shown in my artwork, is that I actually did it on site in the desert, and I would actually go to specific sites and I would create them and then just bring them along with me. But then it really shows you that sometimes if we were to also create the right tools and create the right fabrication methods, that we can really employ and really work on site-specific installation. And I really like how Marcus had really brought up the importance of really working with local materials as well. And really trying to shift this narrative of like having to really always work on creating things indoors or within the borders of a lab, or like trying to just figure things out in this like very comfortable environment, but then actually going out there and really seeing the wind moving and the sand having to move around, and like really actually studying these processes that could be really beneficial to the research.
Probably another one. Sorry.
Please, Al, continue. Yeah. Go ahead.
Another precedent that we can look at his work is Nader Khalili. The way that he not sintering, but the way that he used mud and then try to bake the entire building out of mud from inside out. And he looked at some ceramic pieces and ask himself why they are strong. And the main reason that I think about Nader Khalili because his work in practice shows some implication of Marcus Kayser work. And for sure, Jumana, your work is about this line of practice.
Yeah, I'd like to reiterate this, the potential generation of new tools that can work with existing technologies with sand to bring the potential to build structures or to generate material units on site, I think is important to contrast against how sand is shipped around the globe and around the world, because sand is a very heavy, very dense material, and because of that, it's also very expensive. On site, what's interesting for me about sand are, to get to maybe come back to Neil's question, are the interactions of natural forces. So there's a mathematician named Wes Pegden, who's a math professor at Carnegie Mellon, who he works with conceptual ideas such as if there are a billion grains of sand dropped on top of one another, what would happen? We call this discrete probability theory. And the evidence of this is in one of the things that they're studying there in that particular lab called the Abelian sand pile. And so what happens when you pile a lot of sand, say 1 million or 1 billion grains, onto one dot or one area, and let that sand flow until the toppling kind of settles down to a stable state. In the computer, it's different than what happens in nature. In the computer, it creates a natural fractal pattern. It's an algorithm that uses cellular automata, essentially, where one grain is basically used to move another until they achieve a sustainable, a stable result. And so, it's really interesting because real piles of sand don't generate that kind of spontaneous structure. There's the Abelian sand pile is similar to a cellular automata that one of the very first ones, John Conway's Game of Life, where there's a kind of mini universe that builds upon one particular grain, and then another grain, and then another dot, and another dot. And you can control that basically with a set of numbers between 0 and 4. It's a very simple game. But what's interesting is that what happens in the computer is very different from what happens in nature. In the computer, the sand pile automatically moves towards complex behavior without any kind of special effort to set up the right conditions. And in nature, what becomes really interesting in working with sand is that you have gravity as a constant, which is the angle of repose, slightly different based on aggregate, but it's a constant. And then you have a variable, which is natural forces such as wind. And that's what makes the desert so unbelievably dynamic as a kind of material, situation.
Marcus, can I maybe just throw in another question? I think the question of obviously of environmental use of sand is really super important. I think that the question, of course, that Philippe Bloch also raises is why did all the sand for the Burj Khalifa have to come from Australia? So while he's addressing structural performance, this background question about we should extend those questions to kind of issues of locality, therefore being able to use resources that are available. What in NASA they call in situ resource utilization. I guess what I want to raise an issue that maybe is only tangential to what we're dealing with, but I'm kind of struck by the fact that with the presence of Iranian scholars here, that Manya Maybody has been helping in Michigan, and Al has been working obviously from Iran. I also worked with Baruch Nevis on 3D printing. And I think one of the things that we overlooked when we were talking about we were assuming that one could use some of these kind of techniques we developed for the Moon and Mars on Earth. But I'm not so sure. We didn't actually interrogate the regolith enough. And I think the behavior of the regolith, once we get down to it, we'll have to address all those questions that you're dealing with in terms of different types of sand. But I want to pick up on the kind of, I guess, the I don't use the word intelligence, but the kind of, let's say, the knowledge of materials that has been around for some time. And we need to, I think, revisit many of these things. Just yesterday, I was on a review at Florida International University where I was asking the students why in their environmental designs, they were using air conditioning, because we have this wonderful system that Al knows only too well, both in Iran, actually, also in Saudi Arabia, UAE, and so on, of wind towers, which I think are really intelligent ways of harnessing the logic of natural systems, and we're now going back to those and trying to rediscover the inherent the knowledge that we need to bring back in. We can avoid air conditioning systems. So there are lots of kind of, like, I think, in traditional things that we've kind of overlooked and discarded because they seem to be outdated, but actually it could be revisited. I just wanted to raise one particular question, and this is for you, Al, and that is to say, when I was looking at some of those beautiful, beautiful experiments that you were doing with Nega, really, really interesting, I couldn't help but think that somehow the Mokhanas, which is obviously a very traditional Iranian sort of thing, might have been informed by some of these sort of studies, because within the Mokhanas you get the kind of the bigger vault, but within the vault you get these sub-vaults. And it struck me that they're not so dissimilar to what the kind of the forms that you were kind of you were generating. And maybe that's a tangential question, but I was just intrigued by that. Is there any connection at all?
I don't know. This is beyond my area of understanding and knowledge. But Mukarnas has a very practical solution for a challenge that they had. The base of building is cube or a square base, and to meet the circle or the base of dome, they had to think about how these two geometries, circle and square, are going to meet in between. And maybe it is about function of ornament, the way that they try to solve something and make it more glamorous and beautiful and gorgeous. Unfortunately, I don't know. I hope some other folks know it. But one thing that definitely we know is about the way that they react with forces. Is a kind of pleated, folded surface. And one other things that I think about Mukarnas in a way that it's show the majesty and beauty of light. I had a professor in my bachelor years. He said, to show light, you should make a prison. Or he said, architecture is a kind of prison for light. Light is there. You don't see it. But when you put it in a jail, it's become visible. For sure, Mukarnas, beyond all its functional part, it was about showing the beauty of light. But the country, the whole, I mean, going back to your previous session about clay printing, clay is different from sand, but it is a single material that one civilization made based upon that. When you go to a central city in Iran named Isfahan, the whole city made by soil, and soil turned itself to different kind of artifact, but a single material could, means sometimes we are in doubt about the disposal, the variety of material that we have in our disposal. But if we look at whatever building that we have before modern era, they are mainly made out of 3, 4, 5 material, and that's it. And for centuries, human beings embed knowledge in those material, as you mentioned. And right now, something that is missed in digital era, when lavishly we can use digital tool, and when we think 6-axis robot is going to do everything for us. For many times I ask myself, why should I think about form finding, or what is the use of form finding? As long as it seems we are in a kind of endless world of possibility, at least in a realm of imagination and in a realm of presentation. And it is not a true way to see things nowadays, because of digital tool that all of us use. The notion of material is almost forgotten. We have capacity and power to force material to behave in a way that we want, in a way that we can afford it. And in somehow the knowledge of material that you are talking about is not needed. I don't need to know anything about wood. When I put a piece of trunk under a CNC router, it's going to carve it as I want, period. Sorry, if you started from Mukarnas, I ended up with router.
Yeah.
Sorry.
You know, well, maybe it's a long shot question, but I do think that there's I just want to echo your point about sort of we're kind of focusing on the computation and overlooking and forgetting this kind of understanding of materials from the past. And I want to mention just briefly that the whole notion of the Voronoi comes from. But most people think about it as a kind of computer program, right? But actually, Voronoi was originally developed as a way of sort of understanding the distance between different stars, and it's the line of equidistance of different stars. It was a way of plotting the universe, and it struck me that actually we saw that precisely with your illustration of the work with Nega. That was a Voronoi pattern that was showing it was all to do with the kind of with the same kind of logic. So there's something absolutely fascinating that is there. Yeah.
There is, the concept of pure geometry that comes from sand, and the relationship of that pure geometry when you also apply that to Islamic architecture or architecture that's found in the Middle East is really a striking comparison, because both are really coming from pure geometry. And I wanted to, one thing, Neil, that you mentioned I thought was really interesting, I wanted to come back and touch upon, was the idea of the wind tower, which is kind of this performative system. And I've always thought that the Middle Eastern architecture was more performative as a kind of sectional condition or massing condition than it was as a material condition, my view anyway. I mean, I think some would debate that, but one example of that for sure is the wind tower, where it works purely on wind, stack effect, and building section, passing over specific moments such as high points and low points and water, and then allowing air from above, which is cooler, to enter a space and recycle the ventilation, is incredibly performative kind of invention. But when we look then at the materiality of the vernacular situation in Middle Eastern architecture, it's different, because sand has historically been quite difficult to work with. It always requires some kind of a binder. It's such a loose material that it's different than clay. These conversations that we're having now are much different than the conversations that took place last week with clay and clay printing. It's different than working with earth and rammed earth and these kinds of things. And so, in the UAE, the Middle East, Saudi Arabia, Egypt, we have the use of coral stones, using materials from the ocean, which is kind of a part of the tradition, mud, but mud is sometimes hard to find, shells, animal manure with the presence of people, mangroves, arish, things like this. But sand, oddly enough and interestingly enough, is the most widely available resource, but it's also the material that is probably the most difficult to use, and is not commonly found so much in some of these other materials. And so, it's interesting when we talk about kind of creating, new modes of working with sand, machines, the use of tools and technologies and things, is the ability to kind of bring about that new relationship with sand as a potential material for regional applications, local applications, architecture, these kinds of things.
Marcus, I have a question from you. As long as you invest a good amount of time on sand, what is the environmental aspect of sand? Means how we can get benefit of sand in a way to hold some moist, cool down air, make the air a little bit hot. I remember one interview from Nader Khalili that he talked about wind towers. Some of the wind towers, at least in Iran, are built in areas that we don't have prevailing wind, or in some season there is no wind. And you invest a lot to make something when you don't have wind. But actually, no wind needed. As Nader Khalili explained, we need sun. When we have sun, we can move air from one side to the other side. My question is, beside construction related aspect of sand that we've been talked about them, what might be environmental part of sand?
Well, I'd like to answer briefly and then pass it on to Jumana, because I think, Jumana, your project of using sand and casting and plants, I think would be a really interesting response to Al's question. That's a project that I want to hear more about. I mean, here, whether it's sand or clay or other materials, we have very limited access to water. We do have wind and we do have breeze, but water is something that's very scarce. However, fog and vapor are more readily available, and definitely in certain times of the year. For example, this time of the year, in April, March, February, we have fog conditions that really, it's not so much rain, it's fog that generates water and moisture for landscape, and also for wall types and things. You can visibly see it on the surfaces of walls. And so it brings about this concept of slow change and slow microclimates that I think have been used in this region for centuries. Fog as a source for water, but also then wind and the need for breeze in these kinds of systems. But I'd like to pass that question on to Jumana and maybe ask as a kind of linked question, maybe how your project using sand and plants that you talked about could respond to a kind of climactic idea.
Yeah, absolutely. So there's a really great sort of study that's done on nanoclay. This basically right now is very dominant in the United Arab Emirates. They've actually been one of the first to actually adopt it, to really try to turn the desert into a more agricultural landscape. And what's really interesting is that what we don't realize is that sand, because of its porosity, can really allow for water flow very well as well. And this is why we sort of incorporated it into the facade, although it was really like a very in the conceptual phase, but it's really looking into the porosity of sand. I mean, clay being the first in terms of capillary action. There was really a study that we've done where we've added some water, and then the clay would actually reach to 12 to 20 feet in clay, and then it would reach in sand from 1 to 8 feet, which is not really bad. It's quite feasible, and it could really be used in a way like in the United Arab Emirates, where there's a lot of desert sand that can really be employed to actually incorporate it into buildings and into construction in a way of not really creating bricks or creating the entire buildings, but maybe finding a way to actually move about these systems within the building somehow. It sounds very ambitious, but it's really become such an open dialogue right now, specifically in the United Arab Emirates, because there have been a lot of people shedding the light on the importance of how it can be, desert sand can be really employed, especially since there's this huge expansion of the city right now, specifically Dubai, where it's just like really depleting these desert landscapes, but they're really finding a way to still keep them somehow, but integrate them within our everyday lives, which could be really interesting and really innovative to really find a way to make that happen.
Interesting. Yeah, there's a very limited palette of plants that can grow in sand. You know, we see that when we drive around. There are, you know, there's the gaff tree, and there are other kinds of plants that grow really well here, where I am anyway. For the audience, I'm in Sharjah, but they don't require the same amounts of water and the same kinds of conditions that other plants do, and they actually thrive here. And you know, I couldn't help but think of that when you were presenting that wall section that could use plants, because, you know, this is something that could be, sand could be an insulation layer and then also could support life for other kinds of plants. And it's a completely different kind of green wall, or a different kind of landscaped wall or vertical wall, you know, really using it. It's a kind of desert version of that. You know, it's a completely different sort of atlas of plants that could be there, a different sort of aesthetic, you know, really quite interesting as a potential wall exploration using sand and plants.
No, absolutely. And also thinking of the different states of sand being dry and wet, specifically desert sand, you know, especially since it's so smooth, it actually holds water better than silica would, because silica would just like allow for it to like just flow on its surface, and it doesn't like really stay as much as desert sand. But really like looking into these different states and seeing, you know, what happens if it were to be like, you know, insulated into a wall, for example, like what would happen? And then what happens when it's wet, when it's dry, because specifically also capillary action in buildings is like a definite no-no. So it's really finding ways to insulate it very well, and maybe sand could be a great way to start that dialogue.
Marcus, I wonder if I could just quickly share my screen so that some of the things we've been referring to, people we can't assume everyone knows what a mechanis is or whatever. So if I can just quickly share my screen to show you, this is a mechanis. And I guess what I was saying is these individual sort of subvaults, somehow it reminds me of the way the sand formation. I think there's a research there, Al. I think it'd be fantastic to try and explore that. But, you know, I think it's also interesting that these are kind of Iranian obsessions. It was Farshid Masavi who wrote about the function of ornament. And I somehow see very close links between the way in which sand is now being used and this kind of logic. The other one I was going to mention briefly was also the wind towers, which you may not know, which are really, I think, astonishing things. And this is an example in Dubai. You know, and what's interesting about them is they operate like air conditioning systems. And if you stand underneath one, it's like you're under a blast of an air conditioning system, but it's completely natural, and it's to do with kind of differential air pressures. I'm sure that Al could explain that more. But basically, these are the wind catchers, and they operate in a way very efficiently. And I think importantly, I would say, is that increasingly, as we find that our use of with global warming, the world is becoming more of a desert, that we need to use these systems that we've developed historically to try and resolve some of these questions. So let me just stop sharing that. But and I think there's a lot in sand that really opens up, and I just think that there's a whole chapter that you guys are hinting at, but I think is going to really open up in the years to come. So that's why I think this research is so interesting. If we have, go ahead. Sorry.
Yeah, sorry, Neil. Just to go back to these structures that you just showed. So you also see them in Alhambra as well in Spain, in Granada. And I remember being there and taking a tour and like, just, you know, this is like my touristic knowledge right now, so don't trust it too much. But it's so the inspiration really came from a story that really happened, or a situation that really happened where, you know, the Prophet Muhammad, peace be upon him, and also was really in hiding, and there was this sort of spider web that was sort of protecting and made the enemies go away, because there was a spider web. So it showed that there was nobody there, right? Nobody would have been able to penetrate through, and then it made them go away. And then the inspiration really came from that spider web. That's from my touristic knowledge. But it's also interesting because if you look at the way that the spider web is formed, somehow is that maybe there is some sort of relationship to the vernacular structures as well. Maybe that can also be another dialogue. But yeah, that's like sort of my touristic information over here.
And if you let me share one image that may help us to think about sand in another dimension. If I share this project of Mohammad Reza Godusi in Hormuz Island in Iran. The way that they are made, there are some dome, colorful and playful for sure from different angle, but something that he did, it's aligned with one of Nader Khalili's project that won that he could won for the second time NASA award for moon habitat. In his first proposal, he thought about centering something on the moon, but in the second one that was much more smarter than the first one, he thought, okay, if you have some bags, we can fill bags with sand, with whatever material, and then stack those bags on top of each other, some kind of potato bags. And a prototype that he made, he used a kind of continuous bag, and locally we can fill it with whatever is there. And maybe this is one way to get benefit of sand as it is. The other way that probably we can think about sand is to use it as a formwork. Jumana talked about its property to hold moist in itself, and when we add moist on it, we can compact it in some extent. It's not loose anymore. And we can look at Nishizawa's project that he made a beautiful dome-like building, a kind of bubble-like things a couple of years ago when he compacted just sand and then removed sand underneath of the building. Maybe if we don't have any good formula to use desert sand right now, I think there are other solutions to deal with this awesome and abundant material.
Yeah, great. I'd like to invite Philip to become a part of the conversation if he's interested. We have Philip Yuan with us, who hasn't spoken yet, but he's been listening patiently, I think. Philip, of course, is expert at all things digital fabrication. And I wonder, Philip, if you have any kind of thoughts or comments on perhaps sand as a material, or perhaps thoughts on sand in architecture or fabrication or as a project, something like that.
Thank you, Marcus. I think it's a remarkable talks from three of you. Great opportunity for me to learning the new knowledge and new thinking on the sand. So I think it's great, very interesting because you're talking about different skills, which matters the way how to fabricate or engage into the not only the building skill, but also could be the landscape. I think when you're talking about the wind tunnel, that is extremely important and interesting. Maybe the future human can collaborate with this kind of installation in the city dynamically to animate, organize the sand. Maybe it's not by the human labor, probably by the wind in the desert or in the city to redesign the field, the landscape, infrastructure. That's a large opportunity, actually. I think the skill could be very big. It's not just like a city skill, it could be like in the desert. You can imagine this kind of wind tunnel in the wind corridor in the desert could generate different form. I imagine it's a lot of very interesting possibilities to rethinking on how to collaborate with the nature, including the wind, to reuse the sand material in the future. I actually make some research on the moon over the past 2 years, and I think sand is important on the moon. The moon Earth is very similar. We make a lot simulation how to make the moon's Earth recently. I think it's very close to the sand. But the most important, how to bring as less material as possible to build some building on the moon. Probably you mentioned like the sindering machine could be something the architects in the future can design to rethinking on the solar energy or the laser energy, how to sindering the sand or the moon Earth, collaborating with certain kind of binder. I think the binder is the most important, as Marcus mentioned. But I think the skill matters, or some material performance matters. We should be subdividing in different scenarios for different tests, different materialities. Learning from nature is important, as Janawa talking about the facade. I like that project a lot. I think it's kind of learning the form and to integrate the plantings with the organic form, which could be maybe 3D printed, maybe sindering the sand to make certain form. I think that's a lot of very interesting things I can learn from you. The most important, I think, is a cross-discipline research. I think designers can put forward very interesting artistic idea and creative ideas to rethinking on a lot of possibility. I think the culture background, the local culture can give us a lot of very strong hinge. Maybe that's not the high tech, could be some low tech things. Maybe just like the sand piles. I think it's a very smart idea to generate different form, beautiful form, and also could like make some different bricks and to stacking them, aggregated in different form. I think that's another possibility to rethinking on the sand to make some bricks or brick mansion structures. That's some middle school, maybe not the macro school, a micro, maybe something in between. That could be some also very interesting potential possibility. I think the cross-discipline, for example, in Shanghai, we're looking forward some material scientists to help us to redesign with some basin, some organic basin to collaborate with the sand of the moon Earth. I think that's a profound possibilities. We need to do a lot of tests, and also we need to make the machine, the printer effectors, how to control the temperature, the heat, or the environment. And I think the binders should base on a lot of cross-disciplinary research. And sometimes it should be problem solving ways to define some question you want to solving the structure performance in different scenarios, what kind of motivation you want to approach. I think that should base on some fundamental scientific research working flow. But I think the designers or artists is important, I think, to give us the very strong possibility. You're showing us, like I like your project and this kind of tiles, the piles, the sand piles, Illinois piles, give extremely beautiful sand form. So that's a kind of artwork based on the very interesting ways, like the free auto rethinking on the gravity. I think the gravity and the sand can produce such a beautiful material. The material, I think that's a kind of material intelligence, as you mentioned. It's based on the design and based on the holes you're digging, the leaking, and the gravity. That's the beauty of the nature. We should learning from this kind of collaboration. So thanks a lot for the fantastic talks from all of you. Yeah, we're learning a lot. We have a lot of audience here. I think it's a great opportunity because probably in the big cities, it's difficult to think on the sand, but in Sharjah and in Dubai, it will be apparently very important material you can see every day. So rethinking on that and design with the material, that could be very interesting to put forward some molecular future or some material intelligence, in the future. So thanks for that.
Philip, thank you so much for your input has been extremely insightful, specifically mentioning how we can learn a lot from nature. Because to be honest, I feel like we, especially in digital fabrication, we've gotten so trapped with our equipment that we really forget about the natural processes that happen in nature. And we really speak about the industrial robots being our tireless helpers, always constantly there. They don't get bored, they don't get tired, but also nature is always dynamic, it's moving. Why aren't we not learning from the forces or really working with the forces that are constantly happening, that are not stopping? Which I think could be also a really interesting forthwith to really looking into materials and making as well, which I think is such a great thing that you've really mentioned. And I wanted to just really highlight that. So thank you.
I agree. Yeah, and I think, Philip, your comments are great closing comments, a great way to close the session. We're coming up on 2 hours now, so I think it's the end of our time. And there are a lot of profound thoughts there, I think, that speak to the kind of history, the current condition, and also the future. So that's a great way to end the talk on sand futures. I'd just like to thank very much Jumana and Al and of course Neil and Philip for being here. It's been a really great session, and thanks everybody for watching and participating.
Maybe I could just say a few brief comments as well, Marcus. Thank you for this session. It's really been an incredibly it's opening up a whole chapter, I think, of potential research. I can see the beginnings of that, and I can see the beginnings of a great book on sand coming out from this, actually. It's been super interesting and a very productive one. Just want to mention that we've got, over the next few days, that on Friday we have a session in Spanish on robotic fabrication, followed by next Saturday we have 2 sessions. The first one also hosted by a Digital Futures PhD candidate, Thomas Ivanko, on looking at distributed design and innovation. And then following directly after that, we have a session, again, from the Arabic world. Please join us. All these talks are going to be uploaded onto the Digital Futures YouTube channel. where I have to say that some of them it's very gratifying to see how many views we're getting on some of these things. So thank you not only to Marcus and to the team today, but also the team behind this. There's a huge amount of work that's been going on to this. We are approaching the big summer festival that's going to be taking place at the end of June, for the end of June, in July, with the Digital Consortium, Doctoral Consortium beforehand. This is going to be, this year we're working in language channels, and I think this could open up in an interesting new way into a new audience. So this is we're in planning right now, and we look forward to welcome everyone to that big event in the summer. So thank you everyone for today, and we look forward to further events in the future. Thank you.
Thank you. Bye-bye.
Thank you.
Thank you.